Hello everybody, and welcome to this virtual IGARSS also from my side. I'm Peter Baumann, and I'm going to present a brief overview on the EarthServer Datacube Federation. So, what's it all about? It's about datacubes. Actually, datacubes are accepted today as a cornerstone towards analysis-ready data, whereby actually we need to see that it's not just about analysis, it's also about visualization, it's also about fusion, etc. So generally speaking, it's just so much simpler to work with massive, big Earth data when they come as data cubes. Actually, talking about working with them, we would like to have actionable data cubes, not just a data structure sitting somewhere where I maybe at most can do subsetting in space and time, but actually I would like to be able to ask any question at any time, and please without coding effort, because I don't want to become a programmer. I'm not an IT expert. I'm maybe not even a remote sensing expert, and so actually just allow me to phrase my problem and then the system please should solve it. That actually is something that has been pioneered with the invention of array database systems. And the rasdaman system here was the pioneer technology that has brought up these queryable data cubes that today actually even are found in the standards. So yes, we do have analytic standards in place for data cubes. In OGC, we find the Web Coverage Processing Service, WCPS, as part of the WCS suite. It knows about space-time semantics. And then, in contrast, we have SQL MDA for multidimensional arrays, which actually is the rasdaman query language. It is domain agnostic, so it can just as well handle multidimensional brain images, for example, or cosmological simulations for that matter. Okay, so we have data cubes, we can query them, but still they sit isolated in single installations. But actually very often we want to bring together data from different installations, right? There is one interesting data set, here is another interesting data set. I would like to combine them. So the next step is federation. And that is exactly what's being done in EarthServer. Actually, it's a common pool of multi-petabyte data cubes meantime. That includes SAR data, hyperspectral, climate data, DEM, thematic products contributed by many different data providers. It allows for a completely location-transparent analysis and fusion and visualization of data cubes. So users don't need to know and don't see actually where the data sit. They just can mix and match them freely. The whole thing is based on open standards. It's a completely open service with a community governance, so you could call it without a single point of failure. Actually, it's an open governance. Okay, so large-scale data providers meet here. It's a lineup of satellite climate thematic providers with a list of institutions waiting already to join. So we are handling them one by one to get them into this federation. It's free of charge, and by the way, there is no need for a data center to publish all data. It's enough that you provide some data. That makes us already happy, and that helps users. You're not forced, you're not obliged to anything in any way. So if you feel interested, please contact us to join that. Actually, independent reviewers have attested EarthServer that there is proven evidence that it will significantly transform access and use of Earth data, and with no doubt has been shaping the big Earth data landscape. So this is something that is considered as an interesting step forward to getting data together, to getting these loose ends together. A little bit about the technology. I cannot talk much about that here given this short presentation. It's based on the rasdaman array database system, which allows you to send high-level declarative queries and do analytics on the server. The interfaces are completely based on open standards. By the way, yes, if we have such a federation, we need to think about access control, and that is something that we had to provide. And this, meantime, can be done down to the level of single pixels. The rasdaman is a full stack implementation, not just an add-on to some existing library or so. And it's a highly scalable implementation that gives you responses typically in a few hundred milliseconds. Actually, aside from that pioneer system, increasingly find epigons. Various systems have also jumped on that idea and their attempt. Research Data Alliance in 2018 published a report where there's a comparison. You can find a comparison of 19 different tools there, so I just refer to that for detail. The graphics here show you the principle. We know the language, we know the semantics of it, and so we can see for this incoming gray box, actually we have a yellow part, which the node can answer readily. The yellow part is dataset A, we have it, we can process it. Not so the orange dataset, B. But we know a friend in the cloud that can do that for us, and so we just carve out a subquery, send the subquery to node B, and get back the result. That shows you already that all the nodes can do completely different things, as opposed to what's called embarrassingly parallel, like with Hadoop, for example, or with other tools. At some time we found out that it's not only good for the cloud, but also for getting to different data centers. So the blue part we would send to the blue house, have it processed there, and just get back the result. In a project with the European Space Agency, we are driving that as far as going on board a satellite. We have ported rasdaman to a CubeSat, and there it's up in space now, and that means you can send up queries and get back results. And that is actually the basis for the federation. And as you can see, the user doesn't need to know where dataset A, B, C, and D are. We can do data fusion as we do here at any time, and the systems will actually negotiate and optimize that. Now I'm talking so much about query languages, but I hasten to say no, you don't have to write queries. Actually, you have the freedom of picking any client that supports the standards, and so users can remain in the comfort zone of their well-known tools. You want to do map navigation only? Okay, come with open layers or leaflet. Virtual globes? Okay. NASA Worldwind, etc. can be used just as well. WebGIS or high-end analysis like Python, say through Jupyter Notebooks. So people can come individually with their clients and work simultaneously on the data, seeing their particular view on the data, which is commensurate with what they expect. So, in summary, EarthServer is establishing the first location-transparent Datacube Federation. So users don't need to know where data sit, users don't need to do coding. They actually can access and combine all these data cubes freely. The goal is we want to make it as simple as navigating a map, say Google Maps, for experts and non-experts alike. It's totally open, free, and a quickly growing community of service providers. And so again, let me extend the invitation. If you have some data offerings, contact us and join us. It's completely free and without any particular obligation, except that, well, you should offer at least a little bit of data. So that's it. Thank you for your attention and enjoy the rest of IGARSS. Bye bye now.